Good afternoon, everybody. I'm Michael Lauren Prue. I'm with Corporate Communications, and we'd like to welcome you to our next speaker session of the day. NAVAIR would like to welcome Commander Fleet Readiness Centers, Rear Admiral Joseph Hornbuckle, and Executive Director, Mr. Roy Harris. Now, after a brief overview of COMFRC, they will dive into Fleet Readiness Center reform, one of the 7 pillars of the Naval Sustainment System for Aviation. They will also speak to their commitment to expanding partnerships in their quest to continuously improve upon readiness and sustainment efforts for naval aviation. Now, they will give their presentation today, then we will open up the floor for questions. And I'd like to remind you, we're here live in person, and we are also coming to you virtually on LinkedIn, so we'll be taking those virtual questions as well. And now, without further ado, ladies and gentlemen, COMFRC has the floor.
Hey, Michael, first of all, I'd like to thank you. I'd like to thank Marcia, Julie, and Terry, the entire NAVAIR team, for making this booth possible. We look forward to the next few minutes talking with you. Also, a thanks to Sea Air and Space 2021 for giving us this opportunity to address you. Like Michael said, we'll spend the first few minutes with some prepared remarks and some slides, give you an overview of the work that we're doing at COMFRC, and then we look forward to your questions. So I am thrilled to be here representing COMFRC and our efforts to support effective and efficient flight line readiness through globally managed, responsive, and integrated sustainment systems. Since 2018, with the redefinition of our national defense strategy, we've taken a very close look at what that means for us in the fleet readiness centers. And it essentially comes down to 2 major lines of effort. First, we've got to make sure for near-peer competition that we're providing not only the capabilities, but particularly for us, the capacities to face those threats. The second is we're taking a very close look at our infrastructure, making some very deliberate and thoughtful reinvestments to make sure that we can provide the support that naval aviation needs for the next several decades. So I'll speak to you today about some of our collective efforts we're implementing in concert with the entire naval aviation enterprise. In previous jobs as a fleet aviator, program manager, and most recently as the vice commander at Naval Air Warfare Center Aircraft Division, I came to appreciate one of the most important facets of our business for providing readiness and sustainment is collaboration. Collaboration between the fleet, our engineering and logistic experts, our program offices, and critically, our industry partners. So slide, please. For an overview of the FRCs, we have 9 fleet readiness centers and 25 additional tenant sites that span 5 countries and 13 different U.S. states. COMFRC has a highly skilled workforce of approximately 23,000 that includes active duty, our civilian artisans, as well as industry partners. We support 9 carrier strike groups, 9 carrier air wings, 38 type model series across the breadth of the naval aviation enterprise. In an average year, we repair approximately 500 airframes, 3,000 engines and associated modules, 150,000 individual components, and in addition to that, through our eye-level partnerships, we enable another 120,000 component repairs each year. In April, we were thrilled to stand up the FRC Reserve Midwest Center in Fort Worth, Texas. It stood up as COMFRC's 9th Fleet Readiness Center. The establishment of FRC Reserve Midwest to better position reserve forces from a man, train, and equip perspective and establish a central manager of these capabilities and capacities. Our Reserve Fleet Readiness Center detachments and Reserve Aviation Support detachments were then realigned under the newly formed Fleet Readiness Center Reserve Midwest. I was out there 2 weeks ago, had fantastic interaction with the team out there. Not a sharper group of people, and really digging in to provide everything they can to support the naval aviation enterprise. In an organization this large and dispersed, communication and collaboration are crucial to our successes. We recently had a chance to tour fleet readiness centers on both coasts, and I was absolutely amazed at the passion that our sailors and artisans had for the work that they were doing. Whether it was young sailors working on F-18 generators and generator control units in Lemoore, or young sailors working on ALQ-99 pods, trying to keep those around to support the Growler fleet in Whidbey Island, all the way down to our tremendously talented artisan workforce that are working to reduce PMI turnaround times on the H-60 in Jacksonville, Mayport, and San Diego. So our efforts, one effort that is transforming both readiness and sustainment across our enterprise is the Naval Sustainment System for Aviation, or as we refer to, NSSA. Our FRCs have experienced substantial improvements in workspace layout, times for maintenance, and are doing much more deliberate planning for future activities than we've ever done before. We began these efforts in 2018 across the Super Hornet line, and we're now scaling these efforts across the breadth of naval aviation to include all 38 of those type model series that we support. I'll turn the floor over to our executive director, Mr. Roy Harris, who will walk us some of the nuances of FRC reform, one of the key pillars of NSSA.
Admiral, thank you, sir. Good afternoon, everybody. So I wanted to talk a little bit about the Naval Sustainment System Aviation, or what many people call it, refer to it as NSSA. So look, I'll start by explaining this chart. You can see, I think Michael mentioned in the beginning, there are 7 major pillars of the NSSA activity. And it's really a pretty tight coordination between the fleet, the supply community, and the maintenance community. And I'll walk you through some of the pillars and then focus a little bit more on the FRC reform type activity, which is really what we're here to talk to you all about today. So on the fleet side, if you're following around the circle, there's something called the MOC AOG, which is the Maintenance Optimization Center, or Aircraft on Ground activity. And also on the fleet level, there's something called O-level reform. These were born, like all 7 pillars, out of industry best practices. We partnered with a consulting agency to come in and really leverage commercial airline practices across our organic activity. And from a MOC AOG standpoint and from an O-level reform standpoint, I'll say it this way. I mean, O-level reform is really just trying to focus on optimizing the maintenance that we do right at the flight line in terms of any maintenance that's required or inspections that are required, doing that as quickly and as efficiently as possible. The MOC AOG is a little different mindset, and again, another industry best practice where we really have an operations center. It's centrally located out of Norfolk, where they are looking at all aircraft that are currently on the ground and prioritizing activities, whether it's manpower or supply or parts, really prioritizing those resources to get the aircraft up as quickly as possible. So just a new way of doing business, and again, modeled by an industry best practice. From a supply standpoint, supply chain reform, that's partnering with our NAV, SUP, WSS, and DLA communities. Predominantly, what you'll hear about this community is something called integrated supply chain management. So it's looking at all aspects of what we do from a supply standpoint, whether it's work at the organic depots at the I level or the organic D level, D level work at the commercial level, or all the DLA parts that are required to execute those repairs. We established targets for each TMS, and now we're tracking throughput targets that are required to maintain flight line requirements for that particular type model series. From an FRC standpoint, there's really 2 major areas we get into. One is engineering and maintenance reform, and I'll talk a little bit about that later in the presentation, but it's looking at all the data coming off the aircraft and reevaluating or optimizing, if you will, the maintenance concept of each type model series. And then there's something called FRC reform, and that really is the down and in work that we're doing at the FRCs, looking at the turnaround times for our aircraft, engine, and component level repairs, and driving that down as low as possible. From an FRC reform effort, it really started with the F-18EF. Many may have heard the charge, the Rhino charge of 341. All of these 7 pillars were instrumental in achieving the 341 mission-capable aircraft in the flight line. From an FRC standpoint, we bought in, again, industry best practices, leaned out our production lines, stood up concepts such as a production control center, really looking for tighter collaboration across all communities of the naval aviation enterprise in order for us to repair the commodity, again, whether it's airframe, engines, or components. And I'll tell you that probably the biggest part or improvement, in addition to all the business process improvements we put in place, we're establishing targets for our time model series. Those targets were put in place, or we dug into the analytics. We came up with targeted turnaround times in order to maintain pace or operational requirements on the flight line. And then we challenged our community to hit those targets. And the big cultural shift that I'd like to point out here is in the past where we may have encountered barriers and maybe, I'll say, accepted some of those barriers and accepted not hitting those turnaround times. The cultural mind shift we put in place with NSS was, with that target in mind, what barrier was preventing us from hitting that target, and how could we use the power of the naval aviation enterprise to remove that barrier and maintain target? That was probably the secret sauce that we really looked to implement across all our time model series, setting that target, analytically based, identifying barriers to achieve it, and then swarming those barriers to make sure we hit those turnaround times. So again, that all started with the F-18 events, where we had, and I'll speak airframe events to keep it simple, planned maintenance interval turnaround times of 120 to 150 days. We pretty much cut that in half just by implementing this new way of doing business. Saw significant results with that. We expanded it over to the E-18G Growler and drove that down to a 60-day event as well. And now we're in the throes of expanding it to other platforms. But before I get into those, I think the important part, and maybe 2 years ago when I stood in front of a lot of you talking about the beginnings of NSS, we're kind of in the formative stages, in the beginning stages, and trying to get to 341. I think the prevailing concern or challenge that we had was, hey, once we hit that, would we be able to maintain it into the future? Well, for the F-18EF, we hit that in 2019. We hit the 341 mission capability goal in October of 2019 and have maintained it since. So these principles that we put into place were not just, for lack of a better word, a flash in the pan. They're lasting, permanent changes that we put into place that have allowed us to not only hit, but maintain those flight line requirements for the Super Hornet and now for the Growler. As we've expanded it to other platforms, we have now stood up or applied these principles to all of our production lines at the FRCs. And as we look now towards new platforms like the E-2D, the H-60, the V-22, we're in the throes now of applying those same principles to those PMI events. And again, driving those turnaround times upwards of 50% less than what they currently are at today. So a lot of benefit, a lot of goodness has resulted from our efforts to date in being able to lean out processes, drive down turnaround times, and get aircraft back to the fleet quicker. One last thing I did want to talk about on NSSA, and it's the seventh pillar that I have not mentioned yet. It's called cost reform. So as we started off our NSSA journey, it really focused around 6 of the 7 pillars, with the last one, the 7th one, cost reform, coming into the picture as recently as last year. And the whole precept of the cost reform effort is, now that we've been able to achieve the readiness goals that we're trying to, that we have for each time model series in the flight line, we're now looking very deliberately and very focused to drive costs out of our operations. That applies to all pillar efforts, and specifically the FRCs. We're down and in and looking at the costs at the way we do business and the cost of our operations, and looking to lean out costs to the greatest extent possible, so that not only are we delivering mission capable aircraft much quicker than we had in the past, but we're doing at the lowest possible cost. Okay, with that, we're going to go on to the next chart, and I'm going to turn it over to Admiral Hornbuckle.
Thank you, Roy. So picking it back up with another significant initiative within the FRCs is how we're going to build a more effective repair depot set of installations. The term that we've come up with is Fleet Readiness Center's Infrastructure Optimization Plan, or FIOP. It is designed to reset aviation maintenance most critical facilities and equipment, New aircraft are driving specialized requirements ranging from larger facilities to handle increased size and configuration of our rotary wing aircraft, increased environmental controls supporting some of our most exacting standards associated with our avionics, and many of them will now require enhanced security measures and increased sizes and different configurations of the layout of those shop floors. Changes to the paint intervals requirements are driving the need for additional fleet facilities in order to meet fleet demand, meet environmental demands, and make sure that we continue to battle corrosion that plagues the environments that we operate in. Many platforms are using more advanced composite materials than ever before on both airframes and components. Modern propulsion systems often come with new requirements for dynamic component repair and testing. The intended outcome of FIOP is to revitalize aviation infrastructure to include multi-use sustainment facilities, sufficient power and security available, and to optimize maintenance production configurations in support of the sustainment system that will enable efficient sustainment not only of our legacy platforms, but of our future platforms for decades to come. These investments will ensure COMFRC meets its obligations under the new NSSA systems and deliver an elite organic repair center. In 2019, our Phase 1 FIOP report was submitted to Congress. Phase 1 provided an initial baseline assessment of our most critical production and manufacturing facilities and equipment. We provided an interim update in 2020. FIOP Phase 2 is currently underway, providing comprehensive assessments of our aging facilities and equipment infrastructure, and will result in an enterprise investment strategy and master plan. Both these phases are critical as we chart the course for the infrastructure reform in COMFRC that will need to meet our obligations under NSSA. Mr. Harris?
Thank you, Admiral. So to continue on other COMFRC initiatives, another effort that we have underway, and this kind of ties back to the engineering and maintenance reform activity I mentioned previously, is something called the Maintenance Program Optimization. So this really is looking at the data that we have coming off the aircraft and evaluating or reevaluating or updating or optimizing, if you will, the way we maintain those platforms based on how it's operating out in the fleet. Two real good examples of this that I'd like to point out. One is corrosion. It just is, as many that are familiar with naval aviation know, corrosion routinely eats our lunch. It really is impacting our aircraft. By evaluating the data that's coming off the platform, and again, starting with the Super Hornet community and now expanding it on to other platforms, we're evaluating where corrosion occurs and using that data as a mechanism to be a little bit more preventive at the flight line so that we don't see corrosion within the aircraft as we open up the aircraft on the shop floor at the depots. So it's a very coordinated effort based on the data that we're evaluating, again, with the aircraft, and look into how we can collaboratively and in a very integrated fashion update and optimize that maintenance plan so that we can synchronize events between the O level, I level, and D level to get those aircraft up and operational as quickly as possible. Another major effort that I wanted to talk about was something called the RCB. This is something called, it's an industry best practice. RCB stands for Reliability Control Board. Again, a very data-driven activity where we're evaluating the data and how each system is operating on the aircraft, trying to understand why it may be operating outside its original design spec, and then evaluating different ways or methods, whether it's the way we maintain it or whether we do something as fundamental as a reliability improvement on those components, but figuring out ways to get more time on wing. The last thing I really want to mention on maintenance optimization, and again, as we stand here before you, I want to make sure I introduce Mr. John Grabenstein. John has been brought on board as our Director of Maintenance, really looking to manage this effort across naval aviation. And with John's help, by evaluating the data, again, two outcomes that we're really looking to achieve. One is really looking at the data for the component level and improving time on wing for the components. The second one for the shop floor activity, What do we see coming off the aircraft? How do we evaluate that data? And ultimately, again, with the end goal, I don't think I mentioned this earlier, of attacking the depot level spec and trying to drive hours out of the spec. And just to pause on that one for a moment, look historically, as we looked at the depot level spec and the work that we do within the depots, I think we always tended to see it grow time and time again as aircraft stayed in the fleet longer. Through this maintenance program optimization effort, we're challenging that old paradigm and really looking to see where we can take work out of the depot level spec, again, based on the data and how it's operating out in the fleet to drive hours out of that depot level spec. And again, let that be another mechanism that we can incorporate to drive down turnaround times. Okay, and with that, I'll hand it back over to Admiral Hornbuckle on expanding partnerships.
Thank you, Roy. So the initiatives we've discussed today, along with our expansion of partnerships with organizations like the Defense Logistic Agency, Navy Supply Systems Command, and many of our commercial partners, will enable us to realize increased capability, capacity, and velocity in support of naval aviation. We also capitalize on these relationships to accelerate the development, assessment, and transition of advanced technologies to identify and close readiness and sustainment gaps. Additionally, we will execute agreements and look for new opportunities to streamline and accomplish our mission more efficiently and effectively, with a renewed emphasis on cost and buying power for the Navy and naval aviation. Our alignment with industry continues to be a key enabler in our support of the naval aviation enterprise. We look forward to expanding these partners. And again, I'd like to thank our host here at Sea, Air, and Space 2021 and our host from NavAir. Michael, do we have a few minutes left for a few questions? Okay, thank you. So with that, Mr. Harris, if you want to rejoin me back on stage, we'll leverage the expertise we've got with Mr. Gravenstein and Ms. Somerville, and we'd love to take a few of your questions. Got any online to start?
We actually do.
All right, super.
We have a question virtually. It's from Samantha Gray. She says she's highly interested in working with NSS. She says, how can I find out the RFQs available with NSS?
Where are you going to take that?
How can I find out the RFQs available with NSS?
RFQs.
RFQ.
Request for quotes. Okay.
Gotcha. That's right.
Adrian, do you want to take a stab at that?
So good afternoon, everyone. My name is Adrienne Somerville. I am the COMFRC Acquisition Head Director. So I'm responsible for the requirements owners requirement definition phase and ensuring that that works in alignment with our contracting organization. So we do advertise, of course, ESAM.gov accordingly. We also are getting smarter, and we know people are very social media savvy. So we leverage our social media platforms to include Facebook at our site as well as at our command level. But something I would offer, if you're interested in learning more about COMFRC, one of the things our office does is that we provide a platform for you to connect with the technical users and our requirements owner and share what you think that advanced technology is that may be of interest to COMFRC. And from there, we can kind of get you to some of the right people to hear and listen to what your company and or corporate arena offers. So that's a better way, I think. Of course, you can look for all the government federal postings and things of that nature, but I think it would probably be more prudent to try to make some connections internally.
Thanks, Adrian. Michael, any more?
Questions? Yes, sir.
Crusher, Sea Power Magazine. You talked about corrosion, an internal problem with naval aircraft. There was a time in the past when we had problems with dissimilar materials. You talked about new components in our current aircraft. Have you run into the problem we had in the past where you had a chemical corrosion problem because you had different kind of materials, different kind of metals in the airframes?
Yeah, so I'll take a stab at that. And John, if you want to elaborate, look, I think we've run into pretty much every kind of corrosion problem that we had to deal with within the naval aviation platforms. Chemical ones I'm not as familiar with. more due to the corrosive nature of the environment that we fly within, the different metals they are, as they get exposed to salt water and the like, we've seen corrosion in that regard. But in terms of specific metals or specific material makeup, I would think we probably have, although I don't know of any examples off the top of my head. John, anything to add?
So I don't know of any specific examples off the top of my head, but when Mr. Harris referred to the RCB process, part of that process is you also have what's called the executive RCB. So we look across the naval aviation platforms for systemic degraders, and corrosion is one of the ones that we identified as a systemic degrader. And we've actually stood up a team at NAVAIR and NOC-AD that meets once a month. It's the executive director is Mr. McGillis. He oversees that team, and they're looking at all the data, looking at all the different maps that are cut from all the different platforms, putting it through the data analytics tools to then come up with those common themes. And I'm sure they're looking at the dissimilar metals, but I don't have any specific examples right now.
Thank you, John. Thank you, sir.
All right, we have a couple more minutes. Does anyone else have a question? Okay, gentlemen, thank you so much. Appreciate
Thank you,
being
Michael.
here.
Thank you for the hospitality. Thank you, everybody.